So we're continuing our analysis of the effects of greenhouse gas emissions as a form of global pollution. The last session we looked at the case of private costs, where we just ignored the external costs. So we would look at price being set equal to marginal private cost. Now we want to look at the case where the external costs are taken into account as well. So as before, we value electricity because that provides us with benefits, and that's represented by the demand curve or the marginal private benefit, MPB curve. Now we recognise that society involves two sets of costs. The private costs of labour, capital and materials, that was taken into account by the market. But also we want to recognise that the production of that electricity involved pollution, and there are associated costs of climate change, and we're going to represent those by the marginal external cost, the MEC. And so a society's efficient decision equates what people value it for on the demand side, that's the marginal private benefit, with what it costs to total society of producing that product. So that's the MPC, the marginal private costs, plus the MEC, the marginal external cost, which as we've known is the costs of climate change, involved in higher sea level rises, more challenging agriculture, extra costs to protect our environment, and extra costs of building more robust buildings and adjusting to more severe cyclones, floods, and this sort of thing. So how do we put all this story together? Well, let's again go back to our simple diagram. Again, we've got on the horizontal axis the quantity of the desired product. We've got more electricity, more aluminium, but also it's representing we've got more pollution. So if we're not producing much electricity with coal and gas, there's not much pollution. But as we produce more electricity and consume it, yes, there's more electricity, but also there's much more pollution. And we could just make it nice and simple and say there is a nice linear relationship between the good product, we like electricity, and the bad product, the greenhouse gas pollution. And on the vertical axis, as before, we're going to have the price or cost of the product. Now what we'd done on the market is we had talked about the marginal private cost. So if you wanted to get more electricity involving more labour, capital and machines and dragging in less and less productive outfit, then you have to offer a higher and higher price. So that was the market supply curve. Now we also recognise that there's more pollution and that's causing changes in climate, and that has external costs. This is our marginal external cost. So again we have the argument, as we're producing more and more electricity and transport, producing more pollution, that causes more climate change, that causes more challenges in adjusting to higher sea level rises, more challenges to keep agricultural production up, and so on. So we have this rising cost. And so what we're really interested in is for society, the marginal social cost, which is equal to the marginal private cost plus the marginal external cost. So this curve says if we're producing very little electricity, then we don't need a lot of labour or capital, and we don't have much pollution and climate change. If we're producing a lot of electricity, we need more labour and capital and materials, but we're also producing more pollution, and that has increasing costs of climate change. So this is our society side of the cost story. So let's just reconsider the market solution that we did in the previous session. There we're considering just the marginal private cost, but we also have the demand curve, the downward slope, and we had this equilibrium at point E. And that resulted in an amount of electricity produced at quantity Q, and the market price would just equate marginal private benefit with marginal private cost. So that's the market solution, and it ignores the pollution. Now we go to the society optimum. We take into account the pollution. The demand curve remains exactly as before. That's what you and I are willing to pay for extra units of electricity. But now, instead of the product or industry supply curve, we have society supply curve, this marginal social cost. So if we were to take into account all the costs, we would equate the marginal social cost with the marginal private benefits. We would operate at point A. And note that we would buy and produce less of this electricity, and that the price would be pushed up to reflect the higher costs on society. That is, recognising the social costs of pollution as well as the private costs. So that gives us the market outcome, quantity Q and price P. The society outcome is a smaller quantity Q star produced and consumed, but at a higher price. We also can ask ourselves, what are the benefits to society of moving from what the market quantity Q is to the social optimum quantity Q star? Well, let's think about at quantity Q. Quantity Q, our marginal social costs are all the way up here to A. But we benefit of that extra production only off this demand curve, the distance green. So we would have a net gain of this black area by reducing our production from Q a little bit. And it would pay us to keep reducing it all the way back to Q star. Just at Q star, the last unit of production has a marginal social cost just equal to the marginal private benefits of that consumption. So society would have a whopping big gain of this area A by reducing its pollution. Now that's why economists would argue that reducing pollution from what a market gives us, that is ignoring pollution as if it's a free good, ignoring climate change, bring it into our calculations, will make society better off. So this is a positive sum game. It's worth doing. And of course you might ask, well, why don't we do that? Well, because there are some losers. When we're out here producing at Q, there were some expensive electricity, fossil fuel fired electricity generators operating. They'll go out of business. There were a few people buying that electricity with relatively low marginal private benefits. They're going to have to walk to university instead of driving. Or they're going to have to be more conscientious about regulating the temperature on the air conditioning. So we have some losers. But of course the winners, the people from less climate change, gain even more, and that's this big net gain of area A. So let's pull this story together. Let's compare the market solution with the society allocation. The market considers only marginal private cost. It ignores the external cost. It results in too much production and pollution of pollution-intensive products. In essence, society says we would be better off moving from less coal-fired electricity to more solar and wind-driven electricity. We would be better off doing a little bit more walking and less driving our cars. We would be better off eating a little bit more poultry that's less polluting and less beef and lamb that are more polluting. This is the market failure. So society gives us an efficient resource allocation. It considers the external cost as well as the marginal private cost. So it considers what we call the marginal social cost.